Modeling with Inequalities, Unit 6, Lesson 17. I can use what I know about inequalities to solve real-world problems. So today we're kind of looking at real-world problems and the context in which we're solving. So the idea is to be able to understand what the information is that you're being given. It's not just getting the right number, it's understanding what that number means. So a stage manager of a school musical is trying to figure out how many sandwiches he can order with the $83 he collected from the cast and crew. So he collected money, he's trying to buy sandwiches. Sandwiches cost $5.99 each, so he lets X represent the number of sandwiches he will order. Okay, that's important. So he lets X represent the number of sandwiches he will order. And he writes $5.99X has to be less than or equal to $83. He solves this to two decimal places, getting X is less than or equal to 13.86. So that's the answer he got. So they're telling you what the answer is. Now you have to figure out which of these are valid statements about the situation. So he can call the sandwich shop and order exactly 13.86 sandwiches. Well, no, you can't order part of a sandwich. He can round up and order 14 sandwiches. Well, he has to have less than that, right? He doesn't have enough money to buy 14 sandwiches. He could order 12 sandwiches. He could order 9.5 sandwiches. Well, you can't order half a sandwich. He could order 2 sandwiches. He could order -4 sandwiches. So even though 4 and 6 are possible based on this inequality, they're not realistic based on the context. So it's important that you've got the context. So 3 and 5 were the correct answers. So a mover is loading an elevator with many identical 45-pound boxes. The mover weighs 185 pounds and the elevator can carry at most 2,000 pounds. So what they're saying is the mover is going to have to go up with the elevator. So write an inequality that says that the mover will not overload the elevator on a particular ride. So we know that he has 48 identical boxes plus the weight of the mover has to be less than or equal to 2,000 pounds. So that's my inequality. So if you look at it, you can see that we solved it, and they've got the same inequality we do. So now they want us to solve it. So I'm going to subtract 185 on each side of my inequality, just like I would if it was an equation. I create my zero pair, and I'm trying to see how much is left for the weight of each box. So in my calculator, I'm doing 2,000 minus 185, and I get 1,815 pounds. So now I'm going to divide by the 48 boxes. Because they're identical, they all are going to weigh the same. So that means B is less than or equal to 37.8125. Okay? So now they want us to explain what that solution means. That each box has to weigh less than or equal to 37.8125 pounds. So each box has to weigh 37.8125 pounds or less. Okay? So now it says graph your solutions on to your inequality on the number line. So that means that if my answer is 37.8, so it's going to be somewhere here, I can include that, and it has to be or less. So it can't be 38. It's got to be somewhere between 37 and 38. So then it says, is 5.5 a solution? So the question is, is 5.5 a solution for what? The weight of the boxes. So 5.5 is the number of pounds in each box. So yes, 5.5 pounds per box is an answer. So if the mover asks, how many boxes can I load on the elevator at a time? What would you tell him? You could tell him that as long as the boxes as long as each box holds less than 37.8125 pounds, 48 boxes. All right, 28 students travel on a field trip. They bring a van that can seat 12 students. Elena and Kieran's teacher asks parents to drive cars that seat 3 students each to transport the rest of the students. Elena wonders if she should use the inequality 12 plus 3n is greater than 28, or 12 plus 3n is greater than or equal to 28, to figure out how many cars are needed. Kieran doesn't think it matters in this case. Do you agree with Kieran? Explain your reasoning. Well, it says that you need 28 students. So if we're trying to figure out 28 students, we could have the right number of vehicles to be exactly equal to 28 students. So 12 plus 3n is greater than or equal to 28. The reason why it's this way is because it could include exactly 28 students. So then it says, are inequalities sometimes more helpful than equations? Why or why not? Well, equations give you an exact answer. So equations don't consider solutions that could be more or less. So let's consider the amusement park example that we used a couple of weeks ago. If you do an equation, it says you have to be exactly 5 foot tall. If you're using an inequality, you can be 5 foot tall or greater. So all of those solutions are correct in the solution set. So when you're thinking about it, equations don't consider solutions that could be more or less than the exact answer. And that's what you want, is you want to be able to consider things. There are a lot of situations where things are not going to be exactly the same. The movers' boxes are not going to all contain exactly the same weight. But if they all weigh less than 37 pounds, it'll work. So you kind of have to think about, okay, it's not always going to be perfectly divided or perfectly equal. In the cafeteria, there is one large 10-seat table and many 4-seat tables. Now, we haven't been to the cafeteria in a very long time, but I want you to imagine the booths around the outside and how they sit for students, and then the circle and rectangle tables. So that's kind of giving you an idea. There are enough tables to fit 200 students. Write an inequality whose solution is the possible number of 4-seat tables in the cafeteria. Okay, so we have one 10-seat table plus 4 4-seat tables. And that has to be enough to fit 200 students. So it has to be more than or equal to 200 students, because if it's less than 200 students, then it's not going to fit them all. All right, so I'm going to subtract 10. And I have 4s is greater than 190. So then I'm going to divide by 4 on each side. And s is greater than or equal to 47.5. So if I'm trying to think about how many tables that is, I would need 48 tables, 48 smaller tables. Because you can't have part of a table. All right, so I want you to complete your cool down. It's in Canvas. And then let me know if you have any questions. I hope you have a great rest of your day.